Hello everyone, welcome to Digital Lesson for Students by Department of School Education, Nagaland. I am T. Pungudi, MSc MPhil Mathematics, your math tutor from CD King Higher Secondary School, Science Stream, Jotsama, Kohima. In this session, we are going to start with trigonometric functions. So you have learned trigonometry in class 10 about the trigonometric ratios and their identities and the application of trigonometric ratios in finding the heights and distance, isn't it? So we are going to study those trigonometric ratios. We are going to extend the concept. We are going to extend the concept of trigonometric ratios to trigonometric functions here. We are going to learn, we are in class 10, you have studied only for the acute angles, that is from 0 to 90 degree, between 0 and 90 degree. But we are going to extend that one, that angle, no? We can study for any angle, the trigonometric functions, using one measure that is called radian measure. So we are going to learn what is radian measure first, then we will learn about trigonometric functions for any angle. Alright. The first, let us begin with the basic. Trigonometry, we know it is a Greek word from trigon and metron. It means measuring the sides of a triangle. Earlier it was used only for navigation and engineering, but now currently we use trigonometric functions in almost all the areas, like in predicting the heights of the tides of an ocean, analyzing the musical notes, electrical circuit, state of an atom, and seismology also. So we use everywhere trigonometry. Okay. First let us start with angles. You studied already about what is an angle in your lower classes, but here we define in a different way. See, let us take an ray. This is the starting point O, and if you mention this one as A. Suppose if we rotate this ray till this portion, okay. So here, now the ray is here. Okay. This is called initial side, and this is terminal side. Okay. The angle is, this is angle, we can mention it theta, alpha, gamma, anything you can, it's up to you. This is the measure of rotation. Angle is what? Measure of rotation performed by this ray. To get its terminal side from its initial side. Okay, what is an angle? Angle is a measure of rotation of a given ray about its initial side. Okay, it gives us how much it has traveled. See, the ray, it starts from here and it has traveled to new place, right? This measure of rotation is called angle. Okay, and if we rotate the ray anti-clockwise, then this angle is positive. Angle will be positive. And if we rotate the ray, see, clockwise below, then we take the angle negative. Okay, it will be negative. So we can write this one as A, this is C. So angle AOC will be negative. And here angle AOB will be positive theta. It changes only in the direction, not in the magnitude. Okay, and this O is called, this point is called vertex. The fixed point, no, this is called vertex. Alright. Now, we rotate this ray. See, we start from OA and we go one complete rotation and we come back to its original position. See, we start from here and we rotate this ray, go around and come back to its same place, like this. Alright. So this is called one complete revolution. What is it? One complete revolution. We often see in the wheel, spinning wheels, right? So it makes 6 revolutions, 7 revolutions, we say that. That means it gives us one complete revolution. It comes back to its original pace. That also anti-clockwise. Anti-clockwise. Alright. And now we are going to learn the measurement of angles. There are 2 units to measure. Already you have learned one, that is degree measure. The other one is radian measure. Measurement of angles. The first one is degree measure or sexagesimal system. All right, degree measure or sexagesimal system. This we have already studied, 60 degree, 90 degree, isn't it? So we denote like this, 90 degree, 30 degree. There is a O at the superscript, right? So this is degree. It denotes the degree. So what is a degree? If there is a circle, and we divide this circle into 360 parts. See, we cut into 360 parts. See, 360 parts. And in each part, the angle, no, we measure the angle, right? So that is equal to 1 degree. 1 degree. So we can say that this 1 degree is the measure of an angle which is equal to 1 by 3/60th of 1 revolution. So 1 degree is what? 1 by 3/60th of 1 revolution. That means 1 revolution makes 360 degree. So otherwise we can write 1 revolution equal to 360 degree. 1 degree is equal to 1 by 3/60th of 1 revolution. Otherwise you can say that 1 revolution equal to 360 degree. Okay. Again this degree, this degree, 1 degree is divided into 60 parts. Okay, that is called minutes. 60 minutes. We put 1 dash. This is called minutes. 60 minutes. 1 degree is equal to 60 minutes. And again this minute is divided into 60 seconds. 60 seconds. See, like how we use in the clock, no? Same. R is divided into 60 minutes, and again each minute is divided into 60 seconds, right? Here 1 degree is divided into 60 minutes, and then each minute is divided into 60 seconds. Okay. And here this is 0 degree, right? And if we go, this is 180 degree, right? And suppose this is 30 degree, no? Then minus 30 degree, because it is clockwise direction, right? So minus 30 degree, and this is minus 270 degree. Okay. Plus 270 degree is from here till this. Okay, this is plus 270 degree. If we go clockwise, we take minus, and if we go anti-clockwise, we take plus. Okay. So this is degree measure. The second one is important one, radian measure or circular system. Circular system. Radian measure or circular system. Okay. How we define this? 1 radian, we put C. Okay. 1 radian is defined as the angle subtended at the center of the circle by an arc whose length is equal to the radius of the circle. See, the angle subtended at the center of a circle by an arc whose length is equal to the radius of the circle. That is very important. See, let us take a circle, right? And here is the center O. If this radius has, if the circle has radius R, and if you take an arc length, that is also equal to R unit. Alright, if it is 3 centimeter, this is also 3 centimeter, and here this is again radius r, right? See, this radius r, the arc length is equal to the radius, isn't it? Then in that case it makes 1 radian here. This angle is measured as 1 radian when these three are equal. Okay, these two of course they will be equal because radius of the circle. If you take the arc length, same equal length of this radius, then it makes 1 degree here. So this piece makes 1 radian. Okay, suppose if I take the arc length 2r. See, from here, no, this is 2r length. Okay, and this is r, isn't it? Then what will be its radian here? What will be its angle? So that will be equal to 2r by r. Isn't it? We divide r. We take r and then we take r. 1r make 1 radian, then 2r make 2 radian, isn't it? So this will be equal to 2 radian. Okay, you can put 2c or 2 radian also. Nothing written also, it means the radian measure only. You can just simply write 2 also. Right, but for degree measure it is very compulsory to put that 0 here. Alright, but for radian, if you don't write anything, it is understood that it represents the radian measure. If you put C or if you write radian or if you don't write anything also, it always measure the radian measure. Please take note of this. Okay, don't get confused. And here, what is the circumference of the circle? 2 pi r, isn't it? Circumference of the circle is 2 pi r. Okay, and I want to know what is the angle made by the ray for one complete revolution. So one complete revolution, that is equal to 2 pi r by r, right? We take r. So we have to find out how many pieces are there, isn't it? So how do we find out 2 pi r by r, which gives us 2 pi radian. So this is for one revolution, one complete revolution. So in degree measure, one revolution is equal to 360 degree, but in radian measure, one revolution is equal to 2 pi radian. Alright, okay. Suppose if we take the arc length as L, this is arc length L and the radius is r. Suppose this angle here is theta, then how can we find out this radian measure? So theta will be equal to L by r. Alright, we divide by r, so we get theta equal to L by r. When radius, r is the radius and L is the arc length and theta is the radian measure, then we find out the radian measure by using this formula. This is for only radian measure. This represents the radian measure. Please be careful here. Okay, sometimes you will be given L, you will be given R, and then you may be asked to find out the angle. Right, that time this gives us the radian measure, not the degree measure. Alright, so be careful with that. Next one, let us take a circle, that is unit circle, okay? Unit circle, the circle which has the radius 1 unit. Okay, a circle if it has radius 1 unit, then that is called unit circle. So it is 1 unit. Okay, 1 unit. We do not know what it is, centimeter or feet or meter, but 1 unit we are taking. O is the center, and if we take this as the initial point, okay, now we know that since it is 1 unit, then the arc length will be equal to the radian. Yes or no? We know that. Then now we draw a tangent at this point A. At this point A, let us mark this as 0. This as 0, and here we take the positive numbers, like the real number line. Let it be P. And this is -1, -2, -3, -4, and this is Q. This represents Q. Now what are we going to do? We will just rope this line. If you consider this one as a rope, you just rope this real number on the circle anti-clockwise, this side, OP. You just rope like this. Okay, and this Q you rope it clockwise direction like this, understand. Then here we know that this arc length will be always equal to the radian. So which number touches this, that also represents the radian, right? That means every real number will correspond to the radian, to a radian measure. Conversely also it is true. Every radian measure will correspond to a real number. Therefore, we consider this real number and the radian measure one and the same. Okay, radian measure is nothing but the real number. The real number we can represent it in radian. Okay, this is the relation between the real number and the radian measure. Then the relation between the degree measure and the radian measure is, we know that one complete revolution, if we write it in radian measure, that is equal to 2 pi. And in case of degree measure, that is equal to 360 degree. Therefore, these two are equal, isn't it? Then pi is equal to 360 by 2, that is 180 degree. So therefore, pi is equal to what? 180 degree. We know the real number also for pi, 22 by 7 we use in the mensuration, isn't it? That also we can use. So pi is equal to 180 degree. This is the relation between the degree measure and the radian measure. Okay, and we have, so far we have studied 30 degree, 60 degree, 45 degree, right, 90 degree and 180 degree and 360 degree, right. Now let us convert this into radian measure now. So this one we can write it as pi by 6, because 180 by 6 is 30 degree, and this is pi by 3, and this is pi by 4, and this is pi by 2, and here it is pi, and this is 2 pi. So here afterwards we are going to mention the angle only in radians. We are not going to use it the degree measure, because this one we can extend to any angle, bigger angles. Okay, but this becomes very big numbers like 2440, it is so big, right? So in case of, if you write in case of radian measure, that is easy for us to simplify also. So please remember this, pi by 6 represent 30 degree, pi by 3 represent 60 degree, pi by 4 45 degree, and pi by 2 90 degree, pi 180 degree, 2 pi 360 degree. See, listen, here we did not write radian, and also I did not put C. Still it mentions the radian measure only. Please take note of it. If we don't write anything along with it, that measures radian measure. But for degree measure, this is must to put this 0. Okay, this small circle. This is very important. Okay, in the next class, we are going to learn how to convert the radian measure into degree measure and degree measure to radian measure, and also using this, that theta equal to L by R formula, we are going to solve some problems. Okay, and let me write my mail ID and the WhatsApp number here. If you have any queries, you can always contact me. Thank you.